Hello again. I'm going to now continue talking about integration uses in business, and I want to go into something called consumer surplus. So let's see what we have here. Consumer surplus is based off of demand. So once again, I'm going to draw a demand curve, quantity, and price. And I'm going to make the demand curve, which is the demand of the quantity. And what we're actually going to do here is work with a specific point. So it could be the equilibrium point, but we're just going to call it a random point here. We're going to call it the quantity and we'll give it a little subscript here, S, okay, for surplus. Okay. So let's just say we were right here. We decided we were going to sell this many items, or we wanted to look at this quantity point. So it's associated with a price. Okay. So in general, if we have Q items, the demand curve tells us that we can sell all of them at price point P. So we want to do a couple of things with this. One, we want to talk about, first of all, the willingness to spend. So we want to talk about that if we had Q items, what is the total we could get for them? Now we know what we're selling them for. We're selling them for a P sub S. But keep in mind what we have here. We have over here at the side, let me get a different color for now. I'll erase it in a minute. But we have, if we were to sell this few, somebody would be willing to pay this price point. If we had this many, somebody would be willing to pay this price point, and so on. So basically what we're saying is there's a person over here that will pay this much, then there's a person over here that will pay this amount, and there's a person over here that will pay this amount. So if we could get every single person that wants the item to pay the maximum amount, we'd have quite a bit of money here. So we know that we can't do that, but we can talk about the willingness to spend there. So this person's willing to spend this great amount, but the more of them we have, the less people are willing to spend. So what we've got here, we want the total area under here. So we want to add all these up. So we're trying to get all of this under here. Okay. So that is just the area under a curve. And if we're doing it this way, it would run from 0, which is where it starts, to Q of S. And it would simply be the curve. So we have done that. We'd integrate the curve from 0 to whatever point we wanted. And we could shift that point around. So if we wanted to make more items, we would talk about a higher willingness to spend, although every item we add to it has a lower price point. Okay. So let's kind of break that apart. Let's redraw this. One advantage to doing this in real time is that people have a time that they can kind of absorb material. So let's narrow back down to this specific quantity and price point. So over here we did everything under that curve from 0 to whatever quantity we wanted to look at, and it told us the total amount that people would be willing to spend, which would be the area under here. Now we kind of want to see what people will actually spend. So if we set the price point over here at P of S and we sell Q of them, really what we're selling is this amount here. This is the amount of money that we get in. And we would call this the consumer expenditure. So this is the consumer, didn't expect that to turn into an O. Consumer expenditure. So, what is this? How would we calculate this? Well, it runs again from 0 to Q of S. So we're still doing it from this interval, but we're not going all the way up to the demand curve. We're actually doing it as a rectangle here, which has a height and a width. Well, the width is taken care of by this bound Q of S, and the height is actually P of S, which will be a number. It won't be a variable or an expression there. This is actually a price point. But we would take that price point and we would integrate it in terms of Q. And that would give us under here what the consumer actually spends. Okay, so over here is what, if we took each person, and kind of ranked them, what they're willing to spend in the first graph, and then the second one is what they actually spend. Okay, now let's take a extra part here, and I need a new color here. The rainbow pen is not the idea. Galaxy pen. Let's just use the highlighter for now, and let's do it in a interesting new color. Let's see. Let's take this orange here. So what we actually have up here is money people were willing to spend but didn't have to because of the price point. Okay. So what I've shaded up above the price of interest is what people were willing to spend but didn't have to. So this first person was willing to go all the way up to this high price point because of the price point that was set for P, they didn't have to. They only had to pay up to this blue line. So what we call that is, that shaded area, the consumer surplus. So, how do we do that? Well, once again, it's an interval from 0 to whatever the quantity we're looking at is. So it still runs from basically the x-axis over to this point we've picked. So that's the consumer surplus, and we want this up here. So what do? We talked about the area between two curves. So we would have that as the area under D, which would go all the way to the bottom, which was the willingness to spend. But then we'd have to subtract off what this consumer actually paid, the expenditure. So that would be integrated in terms of Q. So if we took the red curve and subtracted the blue line, that would give me the shaded region. So the consumer surplus is what the consumers actually save. Okay, so this first person over here that was willing to spend a lot of money saves a lot. Okay, by this lower price point. The person over here that wasn't willing to spend as much doesn't save as much, but this is money that was saved in the long run.